Okay, it is 5 o'clock. We will begin. This is a paper that I found. It's a 2018 paper. Just an old paper. I googled old grade 10 math exams, and this was one of the ones that came up. Okay, we're just going to work through this paper for our session today. All right, so the question one, it's always going to start with a question where you either have to factorize or where you have to solve for x or simplify. In fact, solve for x is going to come a bit later on over there. All right, but let's start with the factorization questions. Question 1.1.1. All right, so let's just have a look at this one. And we're going to factorize. The first thing that we can see there is that there is a highest common factor. So we're going to take out the highest common factor. In this case, it is x. So we'll say x, open bracket. If we know when we're factorizing, we are dividing each term with our factor. So if this first term is 4x, if I divide that with x, I'll solely be left with the 4. And if this next term over here is minus x to the power of 3, if I divide that with x, I'll be left with minus x squared. Okay. Just note over here, we're not done yet, because if I look inside this bracket, it can be factorized again. Okay, so we're going to factorize that bracket. I'll leave this x over there. The bracket becomes two sets of brackets. Now, if we remember, this over here is a difference minus difference of two squares. So the 4 is a perfect square and the x squared is a perfect square. So that's a difference of two squares. So when we factorize the difference of two squares, we have the first one square, or the square root of the first one, square root of the last one, and then plus and minus. Okay, plus and minus. So that is the solution for our first question. We factorized fully. What we did was we took out x as a common factor. After that, we noticed inside the bracket there was a difference of two squares. So we factorized that also. How do you factorize the difference of two squares? Two brackets that look exactly the same. Square root of the first one, that's the 2. Square root of the last one, that's the x, and then a plus and a minus. Okay, let's get rid of all of this. And then let's go ahead and do the second one. So the first thing that you notice here with the second one is that there are 3 terms. And if it's 3 terms, it's a trinomial. Okay, 3-term trinomial. This is a basic trinomial in that there's a 1 in front of the x squared. Okay, basic trinomial, there's a 1 in front of the x squared term. So what we do with this one is we write down the factors of our constant. So we have a 54. So let's write down the constant, the factors of 54. 1 is a factor of everything, so 1 times 54. 2 can go in there. 2 times 27. Can 3 go in there? Yes, 3 can go in there. 3 times, let's take our calculators out quickly there. $54 divided by 3, that's 18. Okay, I think we've already found it because we're looking for a plus 15. All right, but let's continue. Other factors. Does 4 go in there? No. 5 in there? No. 6 goes in there. 6 times 9. Right, so those are all our factors. Now what we want to do is we see our middle term. Our middle term is a plus 15. We want to have a pair of factors. So what, maybe this one or this one or this one, those are pairs. We want a pair of factors that is going to give me a plus 15. So if I look at the first pair, if I say 54 and 1, if I add these two numbers together, it's going to give me 55. If I subtract those two numbers, it's going to give me 53. Far away from the 15, so that first pair won't work. If I look at the second pair, if I add those two values, it's going to be 25 or 29. If I subtract, I'll get 25. If I look at the third pair over here, if I add these numbers, so 18 and 3, if I add this, I get a 21. Okay, but that's not my middle term. What about subtracting them? If I subtract these, then I get a 15. So I want that 15 because that's my middle term. So the pairing that we have 3 and 8, those are going to be the factors we use. Okay, so we're going to say 2 sets of brackets. We're going to go with x and x. Whenever it's a basic trinomial, whenever there's a 1 in front of x, we can always do that. The next thing that we're going to do, the 3 and the 18 that we've got, goes inside. Okay, now we need to decide, how did I get my 15? But notice it's a plus 15. So it's a positive 15. How did I get my positive 15? The 18 had to be positive and the 3 had to be negative. The 18 has to be positive and the 3 had to be negative. And we factorized our trinomial. Okay, let's get rid of that. Okay, the next one over there, 1.1.3, there's 4 terms. So immediately once you see 4 terms, there's certain things that you must think about. 4 terms is not going to be difference of squares because we know we have 2 terms. There might be a common factor, so you can look for one, but we can see that out of the 4 terms that we have, there isn't a common factor. Trinomial, no, trinomial was 3 terms. Here we have 4 terms. So when you have 4 terms, it's most likely grouping. So we have to decide what the group is that we want to pick. So sometimes first and second, sometimes first and third, first and fourth, whichever ones, we group 2 or we group 3 to try and factorize those. So I'm going to try and factorize my first 2 and see what I end up with. So if I look at these 2, I see that there's an x as a common, or y is a common factor. I'm going to take y out. So y is out as my common factor. Then this y divided by itself gives me a 1. And then xy divided by y is going to be minus x. So out of these 2 terms, if I take y out as a common factor, that's what I'm left with. If I look at these 2, this looks similar. It's almost the same as not the same though, because the signs are wrong. But we should know how to fix the problem of wrong signs. We fix the problem of wrong signs by taking out a negative as a common factor. So I'm going to take out minus 1 from here. So minus 1, open bracket. If the x gets divided by the minus 1, it's going to be a minus x. And if the plus 1 gets divided, by the minus 1, sorry, if the minus 1 gets divided by the minus 1, it's going to give me a plus 1. Okay, so what we notice now is our brackets are actually the same. So this is a plus 1 minus x, and this is a plus 1 minus x. So the brackets are the same. Once the brackets are the same, the entire bracket is my common factor. The entire bracket is my common factor when we have same brackets. Sorry. Right, so the entire bracket, I'm going to take out 1 minus x is in my bracket. And if the bracket is my common factor, if I divide this term with a common factor, what's left? Only the y. So what am I going to have? I'm going to open my bracket and I'm left with a y. Again, the whole bracket is my common factor. In fact, I should have left that negative. The bracket is my common factor. So what is left? This invisible minus 1 that remains over there, minus 1. Okay, and there we have factorized 1.1.3. What did we do? We did grouping. We grouped 2 of them, the first 2 in fact, and then we wanted to see what was the common factor there, or we used any method of factorization. For us now it was highest common factor. And after doing that, we wanted to see that the second bracket would also look the same as the first bracket. So what we did was we noticed the signs were wrong. And when the signs were wrong, we took a negative out as a common factor to make the signs right. Once the signs were right, then the entire bracket was the common factor. We wrote the bracket, and then we said, if that whole bracket is divided, you're left with a y. If the whole bracket is divided, you're left with a minus 1. Okay, cool. Let's move along. The next question over there, we just have to multiply out, right? Simplify the following expression. So this x, and something that I teach is everything in the one bracket has to multiply with everything in the other bracket. Everything in the one bracket has to multiply with everything in the other. So the x is going to multiply with x squared, x times x squared, x to the power of 3, right? We remember, same basis, add exponents. X multiplies with the negative x, same basis being multiplied, right? It's going to be minus x squared, and then x times the 3 going to be plus 3x. Now it's the 2's turn. 2 multiplies with everything. 2 times x squared, so it's going to be plus 2x squared. 2 times minus x minus 2x. And 2 times 3 is going to be plus 6. Cool. Right, now we look for like terms. There is nothing like the x cubed, but there are 2x squared terms. There are 2x terms. So let's add the like terms. Okay, there's nothing like the x cubed, that will stay there. The x squared terms, minus 1 plus 2 is going to be plus 1x squared. And then the plus 3 minus 2 is going to be plus 1x. And the plus 6 constant remains there. Okay, cool. That one was easy enough. You just have to multiply out. Just remember, everything in the one bracket has to multiply with everything in the other. The next one, we have a fraction minus a fraction. Hopefully we remember how to subtract fractions. Fraction minus fraction. What that means is, or what we need to do is, we need the denominators to be the same. So in this case, what we'll do is we'll multiply with opposite denominators. Okay, that's fine. There's just one thing I want to do before that. I don't like that 2 is in front. I like that my x's come first. So I'm going to change the order there. I want x to be first and I want the 2 to be second. Okay, so let's just write that quickly. So if I change, let me just change that one. If I have 2 minus x and I want the x to be first, this is minus x plus 2. Okay, so that would be fine. But what I'm going to do now is I'm going to take this negative out as a common factor. So if I take a negative out as a common factor, what happens is I would have minus, open bracket, x minus 2. Okay, again, as we mentioned earlier, if you take a negative out as a common factor, all the signs change. That's all I did. Okay, so I'm going to just erase this, but this is what I'm going to do in the denominator. So you're going to see the denominator change a bit. That's exactly what I did, right? Okay, so this is 5 over x plus 3 minus 3 over minus, open bracket, x minus 2. Okay, again, the negative came out as a common factor. Now I see these two negatives here. Those two negatives are going to multiply each other. So I'm going to make this a plus, and I'm going to erase this other one. Okay, it's gone. In fact, because that negative is gone, I actually don't need those brackets. Okay, I'll just rewrite it. I don't need those brackets. It was a x minus 2. Okay, so that's just a little bit nicer that x is in front. Now what I want is denominators need to be the same. How do you get denominators to be the same? You multiply with opposite denominators. So the one on the right hand side, we're going to multiply this. Let's maybe put in another color. We're going to multiply this with x plus 3 on top, and at the bottom x plus 3. Let's put those brackets back. This side, you're going to multiply with x minus 2 on top, and at the bottom x minus 2. Okay, so what we did was we multiplied with opposite denominators, and then what happens? Your denominator becomes the same. Okay, let's see if I can make a new page here. All right, let's just keep writing over here quickly. Let's take this question. All right, let's see if this works. Okay, cool. That's great. Okay, so we're multiplying with opposite denominators. So now the denominator is the same. So my denominator on the left-hand side is going to be x minus 2, x plus 3, plus denominator on the right-hand side, x minus 2, x plus 3. Leave the denominator in factorized form. Don't multiply that out. On top, we're going to multiply out though, because that will be able to simplify. So I'm going to say 5 times x, 5x. 5 times minus 2, minus 10. 3 times x, 3x. 3 times 3 is going to be plus 9. So now we know that if the denominators are the same, you can add or subtract the numerators. Okay, so denominator is going to stay the same. X minus 2. X plus 3. Numerator, so I see like terms again. So there's a x term, there's a x term, they're going to add. Here's a constant, there's a constant, so they will add. Okay, 5 plus 3 is 8x. And minus 10 plus 9 is minus 1. All right, so that's factorized. That's as far as we can go. And that is the next question. Let's see what comes next. All right. Let's erase all of this so I can write here. So this is what we're going to deal with. The very first thing that we need to do, okay, let's note this quickly. There is a multiplication. There's no plus and minuses, okay? So that's nice. Why? Because if there's no plus and minuses, then what we know is that there is one term on top, one term at the bottom, okay? There's certain things that we're allowed to do when there's one term on top and one term at the bottom, so that's why that's nice. Right, so what you want to do here, whenever you have a question like this, is you need the same bases. So what we're going to do is we want prime bases everywhere. That means 25. We're going to change it and we're going to make it 5 squared. Right, so 5 squared, that's still 25. Okay, so instead of 25, I now wrote 5 squared, and then there's that minus x squared, that, or minus x, that's a exponent. I still have to put that exponent there. Okay, so all I did so far was I replaced the 25 with a 5 squared, still 5, well, still 25. The 15, I need to replace the 15 with something that's still 15. Okay, and then my exponent there is x plus 1. What can I make the 15? I remember one prime basis, so I'm going to say 3 times 5. 3 times 5. 3 times 5 is still 15, and they are both prime bases. The bottom, 3 to the power of x times 5 to the power of minus x, they already prime numbers. Okay, so that's nice. That's the first thing, prime bases. The next thing that we want to do is we want to get rid of the brackets that we created. So this 2 is going to multiply, and then we remember our exponential laws. The exponent outside multiplies with all exponents inside. So inside this bracket here, there's a 1 and a 1. There's 2 invisible ones. This exponent needs to multiply with both of them. Okay, so what we're going to have is, I'm going to write over here, we're going to have 5 to the power of minus 2x. And then we're going to have 3 to the power of x plus 1 times 5 to the power of x plus 1. Okay, what happened? Let's put another color. This exponent multiplied with the 2, that's where we got the minus 2x. This entire exponent, x plus 1, multiplies with that exponent of 1. Anything times with 1 stays the same. And again, that entire exponent multiplies with that 1. That's where we get that. Denominator, we didn't change it all, so let's leave denominator the same. 3 to the power of x times 5, and that's a minus x. All right, so we have prime bases. Great. We have one term on top, one term at the bottom. Now we're going to go ahead and use our first and second exponential laws. What's our first and second exponential laws? When multiplying and you have the same basis, you add exponents. When dividing and you have same basis, you subtract exponents. So that's all we're going to do now. So if I look at this, there's a 5 base, there's a 5 base, there's also a 5 base. The ones on top, they are multiplying each other. That's the dot there. They're multiplying. The one at the bottom is dividing. That's why there's that line there, divide. Okay, so all of those are 5 bases. So I'm going to say 5 as a base. This exponent, which is minus 2x. I'm going to add this exponent because they're both on top, so they're multiplying. So I'm going to say plus x plus 1. I'm going to subtract this one because there's a divide, because I'm dividing the one at the bottom. So I'm going to say minus, but that exponent is a minus x, so I'll put a minus x there. All right, so that negative and negative is going to eventually become positive for us. All right, the 3, same thing. So over here, I have a 3 base and a 3 base. This line is divide, so those bases are dividing each other, or those exponent, or those bases are dividing. So it's going to become 3 to the power of x plus 1, and I'm running out of space there, minus this one that's at the bottom, so minus a x. I'm going to just write it over there, minus x. Okay, all right, let's keep going. So now we can add and subtract any like terms in that exponent. So this is going to be 5. That minus is plus. This minus is plus. So that's going to be minus 2x plus x. That's minus 1x plus another x. That's 0x. The x's disappear. So this is gone, that's gone, that's gone. I'm left with only the plus 1, so it's 5 to the power of 1. And similarly, the 3, that x and that minus x is going to cancel out. It's going to give me a 0x. And then I'm going to be left with a 3 to the power of 1. And 5 times 3 is all 15. Okay, so that question simplifies to 15. Okay, let's get rid of everything again. I think I am going to skip through some of the questions. If we do all of the questions, I don't think an hour is going to be sufficient. So I'm going to skip through some. In fact, the higher level questions I'm going to skip. So this over here, this is a higher level question. I'm going to skip it. If you do want the solution, send a message on the group and I will do a solution for you in a short video and maybe share it on the group or on the YouTube channel. Okay, the next question is solving for x. Solving for x, so that is the next question, solving for x. So don't get confused by the first one, because over there's no numbers, right? You do the same thing. So if I exclude this, let's see, make like it's not there. What you see is that there's an x there, there's an x there, so x is our common factor. Okay, so I'm going to take x out as a common factor. So x comes out as a common factor, open bracket. So if this term gets divided by x, I'm going to be left with p. If this term gets divided with x, I'm going to be left with plus q. All right, and this is all equal to a. And we know when we solve for x, what we want is we want x alone on one side. Currently, x is not alone because this whole bracket thing is there. All right, this whole bracket thing is here. So we want to get rid of it. How are we going to get rid of it? We know that we need to what is the x doing? What is that bracket doing to the x? It's multiplying. So we're going to divide by this entire bracket, p plus q. And if you do it on one side, you have to do it on the other side as well. P plus q. So those cancel. So x is alone and x is equal to a over p plus q. Okay, so that's the solution for that one. Don't be scared because there's no numbers. The same things always apply. Okay, all right, let's get rid of all of you. Okay, if that was too fast, then I would suggest just going back in the video. If we spend too much time, we won't get very far. This one over here, 1, 2, 3, 3 terms. Okay, so this is the trinomial. This, however, is an advanced trinomial because there's a 2 there. Okay, so now we need to write down the factors of the first coefficient. So I'm going to say 1 and 2, and I'm going to double up. I'm going to say 2 and 1. And then on the other side of my lines there, I'm going to put the factors of the last one, which is also 1 and 2. So it's a trinomial, so it's going to give, I'm going to get 2 sets of brackets. This is equated to 0. Okay, so I'm going to say equal 0. The difference with this one and the one we dealt with earlier was it wasn't equal to anything. This is an equation. It's equal to 0. The ones we had earlier, those were expressions. You can't solve an expression. You can simplify it, but you can't solve it. For this one, because it's an equation, it's equal to something, we can solve. Right. So we now need to find a pairing. So either I'm going to say this one and this one. I must find a pairing that is going to be able to get me my middle term there. Okay. So I'm going to do this. I'm going to multiply this 1 and that 2. 1 times 2 is 2. And this 1 times that one. 2 times 2 is 2 times 1 is 2. If I have a 2 and a 2, can I add or subtract them to get a 5 or minus 5? Can't work. Okay, so that pair is not going to work. I'm going to try the next one. 2 times 2 is 4. 1 times 1 is 1. Can 4 and 1 get me a minus 5? It can. I would need both of them to be negative. Okay, so those are the ones I'm going to pick. These ones and these ones. Right. So now the ones on my left-hand side are my x coefficients. So it's going to be 2x and 1x. And now I know that the 2 multiplied with another 2. So my 2's have to be in opposite brackets. So the one 2 is there, the other 2 is going to have to be in the opposite bracket so that the 2's can multiply. Obviously, then the 1 would go there. Lastly, we needed both of them to be negative because we needed a minus 5. So then both of these will be negative. Great. So we've done our factorization. But we're not done. Because this is equal to something, we need a solution. So what we're going to do is we understand the something, right? Multiply with something is equal to 0. And if two things multiplying together equals 0. One of them have to be 0. Okay, so we're going to say maybe this one is 0. So 2x minus 1, maybe that's 0. Or maybe this one, 2 minus, or x minus 2. Maybe that one is 0. So one of these was 0. Now these are both linear x to the power of 1. That was quadratic x squared. So now we're going to say add 1 on both sides. 2x equals 1 divided by 2. So x is equal to a half, and the side add 2 on both sides. X is equal to 2. That's a quadratic, so you expect 2 solutions, and they are our 2 solutions. Okay, cool. Let's get rid of that. Okay, the next one over there. So what we see is now x is in our exponent. So how are we going to deal with it when x is in our exponent? So this is what we're going to do. Okay, we want to have again prime bases. Yeah, there was a question earlier. We wanted prime bases. Again, we want prime bases. This is what we're going to do. This half, we should know that this can be brought to the top, right? And what that means is, or how we do that is, if it moves from numerator to denominator or vice versa, the sign on the exponent changes, right? So what that means is I'm going to have 2 to the power of minus 1. This moved to the top, and the sign on the exponent, there was a 1 as an exponent. Now there's a negative 1 as an exponent. Okay, and let's put that in brackets. We still had that exponent, which was 3x plus 1. Right hand side, you have a 32. So you want to put that as a prime base. So you can say 32, that is 2 to the power of, is it 5 to the power of 5? Okay, so now we almost have same bases. This negative 1 as an exponent is preventing us from having same bases. So let's get rid of that. This one, let's multiply it out. So this is 2 to the power of minus 3x. Minus 1 is equal to 2 to the power of 5. Okay, so why do you want same bases? Because we know if our bases are the same, our exponents will be equal. So this thing over here has to equal to that one over there. Okay, what did we say? If our bases are the same, our exponents will be equal. Let's write that down. Minus 3x minus 1, that's the exponent, has to equal to that exponent. And again, this is linear, so we're going to add 1 on both sides, so it's minus 3x equals to 6. Divide by negative 3 on both sides. So x is equal to negative 2. Okay, what happened? We wanted prime bases, so we wanted the same base, in fact, on both sides. Once the bases were the same, we knew that our exponents could be equal. Okay, bases are the same, exponents could be equal. And I see we're almost half an hour in and we are still busy with question 2. I think I'm going to skip through a bit more so that I can get to some of the other questions as well. Again, if there are specific questions that you would want me to look at, please send it in the group and I will get back to you. So the inequality, let's deal with the inequality quickly because it shouldn't take too much time. So there is our m. We want to solve for m. Okay, so again, whenever you want to solve for something, you want to get it alone. Normally we say alone on one side, but this, like, how many sides are here? Okay, so this is in the middle. We want to keep m in the middle. We want to get rid of all of the other stuff. So here's a minus 8. How are you going to get rid of minus 8? You're going to plus 8. So I'm going to plus 8, but if I do it there, I have to do it here as well, and I have to do it there as well. So we plus 8 everywhere. Okay, so now what do I have? Minus 11 plus 8 is minus 3. That symbol is smaller than or equal to, I have a 3m in the middle, 3m. My plus 8 and my minus 8, they cancel each other out. And then that is smaller than 4 plus 8 is 12. All right, so we want to get rid of the 8, the minus 8. We added 8 everywhere. We want to get rid of this 3 as a coefficient. So we're going to divide by 3. Where? Everywhere. So now we would have m. All right, so minus 3 divided by 3 is minus 1. 12 divided by 3 is 4. So we read this as m is greater than or equal to 1. and m is smaller than 4. Right? That's our inequality. Write down the number of integers that satisfy this inequality. So I'm just going to draw this on a number line quickly. If I have a -1, 0, 1, 2, 3, this is a number line. These are integers, right? The values in between would be rational, irrational values, real values, but these are the integers. So they want to know how many integers satisfy this condition. This -1 is included, so I must count it. All right, that's 1, 2, 3, 4, 5. Am I going to include 4? I won't include 4 because that is strictly smaller than. Okay, so the answer there is then 5 integers are in that restriction. Okay, the next question is a simultaneous equation question. Right, get comfortable with the simultaneous equations. Right, they are exceptionally important. Okay, you'll see them in your first or second question, and you will also see them in your functions without a doubt. Okay, so let's solve simultaneously. We know we have some steps for simultaneous equations. We make x or y the subject. So if I look at these two, this one and this one, I think if I look at this one, that one's probably going to be the easiest to get y to be my subject. If I say subject, I mean I want it alone on one side. Okay, so I'm going to do this. I'm going to, this 3 that's here, it's a +3. I'm going to -3 on both sides. So this is going to be 2x minus 3 is equal to -y. I don't like that negative, so I'm going to divide by minus. I'm dividing everything with negative. So this is going to be positive y is equal to -2x plus 3. Okay, right? So now I have this new equation, and I'm going to substitute it into that equation over there. So I'm going to say 5x plus 4. Instead of y, I have an expression for y, and all of that is equal to 21. What's my expression for y? -2x plus 3. And now it's linear. Now it's only x's, only one variable, so we can solve for x. We need to get rid of our brackets, so this 4 is going to multiply in with both of those. Minus 4 times 3 is equal to 12, and that is all equal to 21. Okay, this is linear. So what that means is I want all the x's alone on one side, all of the constants or other stuff on the other side. So I'm going to add, or in fact subtract 12 on both sides, and these are like, so we can add those. 5 minus 8 is -3x, and 21 minus 12 is 9. I want to get rid of the negatives, 3, so divide both sides with -3, and x is equal to -3. We wanted x and y, so we're going to take this 3, and we're going to substitute it back anywhere, but I'm going to go put it in this one, right? Because that one already has y as the subject, and I'll say y is equal to -2, our x was -3, plus 3. -2 times -3 is +6. +6 plus 3 is 9. So there I have my x value and my y value, right? That was our simultaneous question. All right, the next question is number pattern. Okay, so this is the first thing that we're going to do there. What I done the fourth term. Let's check what kind of pattern is this. Okay, they tell us it's a linear pattern. Well, if it is a linear pattern, that means there's a constant difference. So if I say these two terms, if I say 17 minus 20, I'm going to get a -3. If I say these two terms, 14 minus 17, I get a -3. So the fact that these two values are the same, right? Those are my differences. Since they're the same, it's a constant difference. If it's a constant difference, it's a linear pattern. So they already told us linear, so we should expect that. Okay, so then in order to get the next term, we can say 14 minus 3, and that would be 11. So our next term over there would be 11. Right, I'm just going to write it like this quickly. So term 4 is equal to 11. We should get used to that notation. The next question, express or determine the expression for the nth term. So now what we want is we want the general equation. So we know this is linear, so we're going to be able to say Tn equals an plus b. Okay, so because it's linear, we can write that as a general equation. We need to know then a and b, those are unknowns. Now a is our constant difference, and we already figured out that that's minus 3. B, okay, let's first write this down and then I will get to what b is. Okay, so Tn equals An plus b. We said a is equal to minus 3, so this is minus 3n plus b. Right, so the way we're going to think about this is we're going to look at our first pairing over there. So that first pairing, it is T1 is equal to 20. So the n value here is 1. That's the n value. Let's write n is 1. So I'm going to go to this equation and I'm going to go put a 1 as n and a 20 as Tn. So I'm going to say 20 is equal to minus 3 times 1 plus b. And now we'll do some linear stuff to solve for b. Add this on both sides, so 23 is equal to b. N equal to minus 3n plus my 23. Okay, what did I do? I found this 3, that 3 is my constant difference, and then I substituted this first pairing into this equation, and in order to find my b value, and then I expressed my solution as Tn equals. Calculate the number of terms in the sequence. Okay, so they say this is finite. What does finite mean? Or the opposite of infinite. Infinite goes on forever. Finite doesn't go on forever. So what they show us here is that there's a last term. The last term is this one. Okay, so they basically want us to know what is the, or they're basically asking us what is the n value there. So we have this general equation, and if they give this number that's in the sequence, that's Tn. So we will say Tn is minus 103 is equal to minus 3n plus 23. And now it's a matter of solving for n. So I want to get n alone. I'm going to subtract that on both sides with minus 126 is equal to minus 3n. Divide both sides with minus 3. So n is equal to, I think that is 42. Okay, just some things to maybe note. Whenever you're solving for n, you have to end up with a positive value. You can't have a negative because it's a place value. And also, whenever you're solving for n, you can't have a fraction as well. Right? It has to be an integer. Okay, cool. All right, I think I'm going to skip through there. Here is a function question. Let's check on our time. I think I'm going to do one function question, and then we're going to call it. I think I've been speaking long enough now. All right. Again, if you find questions you want me to cover and maybe make videos on, send it in the group, and I will deal with those. Now, it's sketched below are the graphs of f. Now, we can see that that is a quadratic. Right? There's an x squared, so that means it's a quadratic. We know quadratics are parabolas. So f is this one. They do also tell us that there. They show me that's f. And then they say there's an A and there's a Q. So I'm going to probably have to find those at some point. Then they say G. If I look at this, I know X is the exponent. That's an exponential function. So this over here is my exponential function. And they also show me the G over there. Okay. There's nothing to solve there. They give us the entire equation. They give me the B value. That's the B value. And then they also give me the Q value. That's the Q value generally. So we should know what all of those do and how they impact our function before we even get there. They tell us A and B are the x-intercepts. There's a A and a B. Those are the x-intercepts of the parabola. They tell me A is a point of intersection between the two graphs. So already, if the two graphs meet there, we know if we solve simultaneously, we would find that point, right? There's another point there. So if you solve simultaneously, you'd find those two. But anyway, let's keep going. E is a point on the graph, random dot. C is the turning point of F. And D is the y-intercept of G. There we go. Okay, great. So all of that they tell us. Let's check the questions. Determine the coordinates of D. They just told us D is a y-intercept. How do I find y? How do I find the y-intercept? Y-int. We know that we're going to make x equal 0. Right? This is the y-axis. And we know that everywhere on the y-axis, x equals 0. The equation of the y-axis is x equals 0. That's the equation of the line. So everywhere on the y-axis x is 0. That's why we make x equal to 0. We have the equation of g, which is our exponential. We have that equation. So let's take the equation and go make x 0. So I'm going to write it in terms of y. I'm going to say y is equal to a half. Remember, that must go in brackets, to the power of 0 minus 4. We know anything to the power of 0 is 1. So this is 1 minus 4. And I think that is still minus 3. So the coordinate, remember coordinate as an x and a y. The x value is what? 0. X value is 0. And the y value we just found as minus 3. Okay. So remember, whenever you're finding a y-intercept, x is equal to 0. Similarly, if you're finding an x-intercept, y is going to be 0. So everywhere on your x-axis, y is equal to 0. All right, so over there, y is 0. Over there, y is 0. Everywhere on the x-axis, y is equal to 0. The equation of the x-axis is y equals 0. Okay, let's see what's next. Determine the range. Okay, so we know range refers to all possible y values. So g is our exponential function. So what can y be? When we think about the range, we want to think of a horizontal line. There's a horizontal line, and if I take this horizontal line and I move it, okay, don't think I can. Maybe I can move it. Okay, take this horizontal line and I move it. Okay, where am I going to be touching g? Now g is the exponential. Okay, so if I put it over here where it currently is, am I touching g? No, it's not. So this is outside of the range because this is not touching the graph. Okay, if I move it up over here, is it touching? I'm on the asymptote. It's not touching. I move it higher. Okay, I've touched. Okay, so let's just show over here. And there I'm touching my graph, and because it's touching, I am within the range now. Okay, so let's just take it again. And if I move it again, I'm touching, and I keep going up, I keep touching. Okay, so where do I keep touching the function? If you see the arrow there, this function continues infinitely. So as I go up, I'm gonna keep touching the function. Okay, right. So it starts at some point, this point, which is our asymptote, and all values up. So we're gonna say, and there's multiple ways of expressing the range. I like to use my interval notation. So I would say that y is an element. I always start with the smallest values. So this value is minus 4. We know that because that's the asymptote. How do you find the asymptote? That value over there. So the constant, which is normally our q value for our or some of our functions at least, that value is my horizontal asymptote. So from the minus 4, and we said it's gonna keep touching infinitely, so it's gonna go up until infinity. Then I need a set of brackets. That bracket's excluded because you can never touch infinity. And then an asymptote, the definition of an asymptote, a line the graph strives towards but never touches. Okay, so the 4, negative 4 rather, is also excluded. That's one of the ways you can express it. It's not the only way. Another way I can say the same thing is by saying y is greater than minus 4. So either I write this or I write that as my range. Okay, let's see what next. Determine the coordinate of A. Alright, so again, we mentioned some things about A. Let's just clear all of these things. We mentioned some things about A. We said A was a point where both graphs meet. And we said A was the x-intercept. It's the x-intercept of both functions. So I'm going to use G because I can't use F. I don't have information about F. So I'm going to use G to find A. So I'm going to say y is equal to a half to the power of x minus 4. I just wrote down the equation. And now it's an x-intercept. So how do I find the x-intercept? Y must be 0. So instead of y, I'm going to take my y away. Instead of y, I'm going to make it 0. Again, a matter of solving for x. So I'm going to add that on both sides. So 4 is equal to a half to the power of x. We dealt with a question like this earlier, right? What we wanted same basis, prime basis. So we want the 4, we're going to change it to become 2 squared. And again, half, we mentioned earlier, is going to be 2 to the power of minus 1. and then the x is the exponent. Right, this multiplies with that one. So it's 2 to the power of 2 is equal to 2 to the power of minus x. Again, bases are the same. So if bases are the same, exponents must be equal. So x will equal to minus 2. Okay. So that means that the coordinate of A is minus 2 as an x and 0 as a y. Remember, coordinate as an x and a y value. Okay. The values of A and Q. So those, let's go back there quickly. Those are these values. There's a A, there's a Q. Those are the values we want to find. So basically what they're asking us is they want us to find the equation of the parabola. That's what they're saying. Okay. So let's do that quickly. In order to find the equation of any function, we're going to start by writing down the general equation, which they gave us. So we'll say y is equal to ax squared plus q. Now what we know, in fact, there are multiple forms of the equation of a parabola. That's one. Another one that we know is we know y is equal to a, open bracket, x minus x1, x minus x2. Right? And this form we call the turning point, not the turning point form, this form we call the intercept form. We use that form when we have the x intercepts. Okay, so we have a. What we also know about the parabola is a parabola is symmetrical. So what that means is the same that it's on the one side, it is on the other side. So in order for me to go from 0 to A, I have to move the same space for me to go from 0 to B. So what would the coordinate of B be without doing any work? 2, 0. If I had to go 2 units that way, 2 units that way, I would get B. Okay, so now we have both x intercepts, so we can use this intercept form. All right, so I'm going to say y is equal to a, open bracket, x minus, just leave a blank space there for now, x minus. So in my blank space that I've left, I need to put my x intercepts. The one was minus 2, so let's put the minus 2 there. And the other one was positive 2. Right? The negative needs a bracket, the positive doesn't need a bracket because the negative, with the positive, it doesn't matter, it doesn't change anything. With a negative, these two negatives are going to multiply. That's why the bracket's important. So now I've got y is equal to a, x plus 2, and x minus 2. You have the option of multiplying this out and simplifying that. I'm not going to do that though. I'm going to leave it like this for a second, and I'm going to check. I have one unknown, and we should know if I have one unknown, I need one coordinate. We can't use our x-intercepts. If we use those and we go substitute in there, we'll end up with 0 equals 0, which won't make much sense. All right. So we are going to have to take this coordinate, which is another dot on the parabola, and substitute it in. So it's 1 and 3. So we're going to put 1 and 3 in. So wherever you see y, we're going to put a 3. And wherever you see x, we're going to put a 1. 1, 1. Okay, now let's continue solving this. So 3 is equal to a. 1 plus 2 is 3. 1 minus 2 is minus 1. Okay, so this is 3 is equal to a. 3 times minus 1 is minus 3, so it's minus 3a. Divide both sides with my minus 3. So a is equal to minus 1. I'm going to take that minus 1 and go back there. Okay, so then I'm going to say y is equal to minus 1, open bracket, x plus 2, x minus 2. Now we'll multiply all of this out. Okay, so I'm going to say x times x, that minus 1, leave it over there. X times x is x squared, x times minus 2 is minus 2x, positive 2 times x is plus 2x, plus 2 times minus 2 is minus 4. Okay, we could have already expected those to disappear because we see it looks like a difference of 2 squares. So these are like, and they are both plus 2 and minus 2, so they'll disappear. So I'm going to have minus 1, open bracket, x squared, minus 4. This negative has to multiply in. So it is now minus x squared plus 4. There's our equation, right? This was y. Y is equal to that. Now let's just go back to the top quickly. Over here, we saw that that was A and that was Q. So we need to know, okay, this over here is A and this over here is Q. Right, that's what they asked for. They asked what is A and what is Q, and we have solved for that. Okay, the length of, okay, we've written a lot of stuff here. Let's clear some space quickly. The length of CD, okay, CD is here. So we already know C, okay? What is C? C is the y-intercept of our parabola. We should already know that that's our Q value. So the coordinate there would be 0 as an x and positive 4 as a y, right? Why? How do we know that? Because that C is the y-intercept. The y-intercept is our Q value for the parabola. And then D is the y-intercept of the exponential. Did we find it? I don't think we found it yet. So let's take the exponential. The exponential was y is equal to half minus 4. And we want to find, this is a y-intercept, so x must become 0. I feel like we did this. Yeah, we did it. We found the coordinate of D earlier, and it was minus 3. Okay. Right, so if this is a nice vertical line, we don't have to go use analytical geometry for a vertical line. We can just say, well, this had to go up 1, 2, 3, 4, 5, 6, 7. I had to go up 7 times for it to go from minus 3 to 4. So the length of CD is going to be 7. Okay, right. Let's clear some of this. Determine the equation of a straight line through AD. Okay, so let's clear. Right, let's just put some of the information back that we're going to need. So A, we said was minus 2 and 0, and D was 0 and minus 3. The straight line is somewhere over here. Right, that's where it is. It goes through A and it goes through D, and you need to find the equation of that line. So if it's a straight line, what you know is y equals mx plus c. So we can say y equals mx plus c. You need to find m and c. How do you find m? This is a straight line. We have a gradient equation, so we'll say y, or m is equal to y2 minus y1 over x2 minus x1. Okay, right, so let's go plug in these coordinates. I'm going to use this one first. So I'm going to say that x value is minus 2 and that y value is 0. Then there's negatives in the middle, and I'm going to put in this coordinate next. The x value is 0 and the y value is minus 3. Okay, simplify that. Minus minus becomes positive 3. 2 minus 0 is minus 2. So I've got my m value that I'm going to put back in there. Okay, and then I must find c. So I'm going to say y is equal to, was it 3 over 2 negative x plus c. I need to find c, but we should already know what c is on a straight line. C is the y value of the y-intercept, and we again have that as d. So then our c value is minus 3. Okay, and that was the equation of our straight line. Okay, let's answer these last two questions, and I think we're going to call it. Right, okay, so determine the values for x. So what I'm going to do is this. Okay, let me just erase more of this. I'm going to draw in a vertical line, not a vertical. Yes, a vertical line this time. Last time it was a horizontal line when we were discussing the range. I'm going to draw in a vertical line. Okay, erase some more. Here is my vertical line. Okay, nice vertical line. And I'm going to move this vertical line. So let's take it and we're going to move it. Right. And I'm going to check where it meets certain requirements. So I'm going to, the function we're talking about is f. F is the parabola. So let's just draw this parabola quickly. Right. So now this is what we're going to do. And we're going to say where is f bigger? So this is, I'm looking at this one. Where is f bigger than 0? So we know that this, we think of our y values. So where's the y values bigger than 0? Y is bigger than 0 on top of this line, right? On top of the x-axis. So we are trying to figure out where is that parabola bigger than 0? Where's the parabola on top? So I'm going to move this line and I'm going to say over here, is my parabola on top? Well, no, clearly not. It's at the bottom, right? So red is at the bottom over there. We can clearly see that red is at the bottom over there. Okay. So we want to move it so that our line that I've got over there, this line that I'm moving, my vertical line, touches red on top. So, okay, it's still at the bottom, bottom. There it's equal to 0. And here it's on top. Okay. So if my red line is there, or my black line is there, touches the red function there on top. Okay. So let's move it again. If this line moves, that's at the bottom, it's on top now. Top, still on top, at 0 again, now it's at the bottom. So the question's saying, from where to where is that red function on top? Clearly, it's on top from this point all the way to this point. So if I do this, space, the graph is on top. Okay, so what are those values? We are looking for x values. The x value over here was -2. The x value over there was +2. So our solution will be, let's erase this. Our solution will be x is an element. Again, I'm using interval notation. I'll show you the other notation as well. X is an element from the -2 until the 2. But remember, we don't want 0, so we're going to exclude both of these values. The other notation, if you want it, would be x is in between -2 and 2. So this is saying that x is greater than -2, and it is saying that x is smaller than +2. So that's the other notation. If you use this notation, always remember this. These inequalities, right? Those arrows must face the same direction. You can't have inequalities facing the directions in a single inequality. Okay, cool. So those are the two options. And then the last one, where is f decreasing? So this is you, and you are walking along the graph. You always walk left to right. That's left to right. So if you're walking here, are you increasing or decreasing? You're increasing because you're going up. The question wants to know where you start decreasing. As you walk there, you're still walking up. But once you get here, that's our turning point. You start walking down. So when you're walking down, you're decreasing. So from where to where are you decreasing? You're decreasing from, what's the x value here? The x value is 0. So from 0 until infinity, that's where you are decreasing. So our solution for that one, again, I'm going to use my interval notation. I am from x, from the 0. I start decreasing at 0, and I go until infinity. Infinity is never included. And I am, so the turning point is something we call a stationary point. So we're going to say that we're excluding that because stationary, so we're not going up or down. Right, we're going to cut it there. It's been an hour, it's been long. So we'll leave it at that. Again, if you have questions, please send it in the group. I will try to make a video pertaining to that. I don't know if we'll have another session before your paper, because obviously there are more questions that you need to cover. There's more functions, there's finance, there's probability. So there is still a bunch of things that we do need to speak about, or you need to still cover in your studies. Right, but good luck. I'll possibly have another session before paper 2. I'm not sure if I'll do another one for paper 1, but I will do one before paper 2. If there's any questions pertaining to paper 1, send it in the group and I'll make some videos. Good luck.